So, good evening, dear students. Today in this class of physics, we will deal with relative motion and the concept of inertial and non-inertial frame reference frame. So, let us go to our whiteboard screen and analyze the things. So, here, suppose there are two boys called Jack and one more boy called Mary. Mary is a girl, I can say. And suppose Jack is running faster, suppose he is running by suppose 30 meters per second, and Mary is a bit slower but moving at 20 meters per second. And if I need to ask how much fast Jack is moving or running with respect to Mary, so I can write the velocity of Jack with respect to Mary will be velocity of Jack that will be with respect to ground, because I have taken here the reference is ground, and velocity of Mary with respect to ground, and this will be about 30 minus 20. So I will get about 10 meters per second. Okay. Now suppose we need to also discuss sometime position of certain things. Means suppose there are two coordinate system. Suppose this is my first coordinate system, frame 1 I will say. This is my frame 1 from where I measure the position, velocity, acceleration of anything that is called frame. And suppose I will draw a parallel from here. Suppose this is my frame 2. Okay. And if there is a point P here, and if I need to measure, suppose this is the position of point P with respect to frame 1, so I will write as R, and with respect to frame 2, if this is the position, suppose R prime, and suppose frame 2 is a position of R vector. This is my R vector. So from here we can see that we can easily write that R vector equal to R vector, capital R, plus R prime vector. Means position of this point P with respect to frame 2, we can easily analyze as R prime will be R vector minus R vector, capital R vector. Means this is the position of point P with respect to frame 1 minus position of frame 2 with respect to frame 1. Okay. Or I can say if I need to measure the position of point P with respect to frame 1, so I can write as position of frame 2, position of point P with respect to frame 2 plus position of frame 2 with respect to frame 1. Now this is the situation. Now let us consider another case. So inertial reference frame is that frame which is either at rest or moving with a constant speed. Okay, or constant velocity we can say. A frame inertial reference frame which are moving with which are moving with constant velocity, which are at rest, which are at rest or moving with constant velocity. Those frames are called inertial reference frames. Okay. Now suppose I have I have this frame only, and suppose if my second frame is now my second frame is suppose is moving with a certain speed with respect to first frame. If my second frame, this is my first frame, that will be 4. And if my second frame, which is initially here, 4 prime, and this is my particle P. Suppose this particle is also moving with a certain velocity. So earlier it is at this point. Now this particle is also moving with a certain velocity. Suppose that I am giving a P is there. So this will be my R vector. Now this will be my some other vector. So I can write as R1 vector now. And suppose this string is also moving with a velocity, constant velocity. Suppose I am writing here V. Suppose this string is moving with a constant velocity V naught. Okay. So after some time, this frame has come here. So this is my now new distance, and this is called RT. I will write as RT. RT is nothing but earlier it will be R plus V naught into T. RT is RT vector is RT vector into velocity of this train with respect to this train. It is moving with the velocity V naught, and it is moving with the velocity. Suppose it has also changed its position, so I can write it. So the new position, this will be the new position. So I can write as R2. So from here again, I will write as. So what we have earlier we have this set of equation. So I can write from here only, I can write as R prime equal to R vector minus of R vector. Okay. And if I differentiate dr prime upon dt equal to dr vector upon dt minus of dr capital R upon dt. So from here we will obtain as dr prime. Dr prime, its position, p position is also changing with respect to earlier it is at this position, and now its position is also changing. So I will write as velocity of this frame, this point p with respect to frame 2 will be velocity of point p with respect to frame 1, that will be v, and this is dr, velocity of this frame with respect to first frame, that will be v naught. So this is the final equation, and it is immensely helpful in dealing with relative motion process. Suppose we also need to find acceleration. So I can write as I have made here that the all the velocity are constant. Either this is changing position or this is changing position. All the velocity are constant. So what I can write? I can write as d upon dt equal dv upon dt minus dv naught upon dt. Now this is constant. This value will be this value will be and it is moving. It is just changing position. So I can write as acceleration in frame 2 will be equal to acceleration in frame 1. Okay. So here I can apply Newton's laws of motion very easily. If the frames are inertial and we can apply force equal to mass into acceleration in frame 1 and in frame 2 also force equal to mass into acceleration, but this acceleration a dash and a are equal, so you don't have to bother about Newton's laws of motion. Okay. Now coming back to the non-inertial frame, so for non-inertial frame, now this velocity is not constant because this velocity is also changing. And how we will deal about the non-inertial frame? Velocity, if it is changing, so equation will be velocity changing. So for non-inertial, that is dv dash on dt equal to dv upon dt minus dv naught upon dt. So we have arrived acceleration a prime in the second frame. Acceleration of point P with respect to second frame will be acceleration of point P with respect to first frame minus dv naught upon T. That is also changing. And if I suppose I have taken this will uh, acceleration of this frame will be a naught. So I can write as a naught. And if I multiply by mass, so mass into acceleration equal to mass into acceleration here also and mi naught. Now this is called real force. This is F real. This will be F real, and this will be F fictitious. 50 ts force, and this will be real force because my particle is in first frame only. So where the forces are actually being applied, and we are measuring from second frame. So this is the 50 ts force, and this is the force on the particle with respect to second frame. Okay. So I can write as F particle with respect to second frame. That will be F particle with respect to second frame will be F real minus F. So in this way, we can see that those frames which are actually accelerating with respect to another frame, they are called non-inertial frame. Okay. So based on the above discussion, we will try to solve one problem from Irodov. So we will see here Irodov problem. You see, the question is given as an elevator car whose floor to ceiling distance is equal to 2.7 meter. Start ascending with constant acceleration 1.2 meter per second square. 2 seconds after the start, a bolt begins falling from the ceiling of the car. Find the bolt free fall time, the displacement and distance covered by the bolt during the free fall in the reference frame to the elevator shaft. So coming back to the question again. So we have here elevator. This is the elevator which is moving by 1.2 meter per second square. Okay, and there is a bolt here. Suppose there is a bolt. So if I draw bolt by this, now after 2 seconds of its start, after 2 seconds, elevator suppose has reached this much height. So and the bolt will fall after 2 seconds. So we need to find how much for how much time the bolt is in means during the free fall is in free fall. How much time the bolt is in free fall, and this distance has been given as 2.7 meters. So you can see that suppose I can see that acceleration of bolt with respect to ground, if I need to find out, that will be given as acceleration of bolt with respect to lift. Same thing, but we have discussed here like that. Acceleration of point P with respect to one frame will be acceleration this one, and this is acceleration, and finally acceleration 1, 2, or this will be A0. So A1 we can write as A0 plus A2. Okay. So similarly, acceleration of bolt with respect to ground, we can write as acceleration of bolt with respect to lift plus acceleration of lift with respect to ground. Now, acceleration of bolt with respect to lift, I can write the acceleration of bolt with respect to ground. Suppose I see from here, then when it is released, it has only acceleration G is acting downward direction. So for my cases, it has reached up to H equal to 1.2 into 2 seconds. So it will be 2.4 meters. 2 into 2 upon 2. Half ET, half ET. Or whatever. 2 plus half ET square. So it will be 1.2 into 2 into 2 into 2. So it will be 2.4. Okay. So now acceleration of bolt with respect to lift will be acceleration of bolt with respect to ground. That will be minus 3. Acceleration of bolt with respect to acceleration of bolt with respect to lift. Acceleration acceleration of bolt with respect to ground minus acceleration of lift with respect to ground. That will be acceleration of bolt with respect to ground will be minus g, and acceleration lift with respect to ground, that will be minus 1.2. So it will be minus 9.8, and this will be minus 1.2. So it will be 11. Okay. So if I come in the reference frame of this lift, and if I measure the everything, so I can see that this situation very simplify very easily. So I can see that it needs to travel only 2.7 meter. It needs to travel only 2.7 meters. It needs to travel only 2.7 meters. So I can write as displacement equation x equal s equal to u of bolt with respect to lift into t plus half of bolt with respect to lift into t square. And this t we need to find. Now, u of bolt with respect to lift, this bolt is stationary because suppose in 2 seconds this lift has got a speed of u is 0 plus 1.2 into t, that will be 2.4 meter per second. So this bolt also has a speed of 2.4 meter per second with respect to ground, but with respect to this lift, this bolt has a speed of if I write here uh, bolt with respect to lift equal to this bolt with respect to ground, this lift with respect to ground, and they both have a speed of 2.4. So 2.4 minus 2.4, that will be 0. So this term will be 0. 0 into t 0. So I will have half. Acceleration will be, suppose this will be minus 11. So I will write here minus 11 into t square. And this displacement, my position is here. Positive direction is upward direction is positive. So this direction will be negative. So I will write here as minus of 2.7. Minus 2.7. So based on doing that, I got 2 into 2.7 upon 11 under root. So it will be about 0.7 seconds, which is my first answer. This is my first answer. 0.7 seconds is my first answer. Now after that, question is asking about range and question is asking about the displacement and resistance covered by bolt during the free fall in the reference frame fixed to the elevator shaft. Actually, elevator shaft is fixed to the ground. So we need to find the distance and displacement of the bolt with respect to ground. Distance and displacement of the bolt with respect to ground we need to find. Problem. So we need to find what we need to find. We need to find distance and displacement. Distance and displacement with respect to ground. So our lift, which will initially start from here, after 2 seconds, it has moved here. That will be This distance will be 2.4, I think so. So when the bolt from here starts falling after 2 seconds, so in 2 seconds also, after 2 seconds, suppose the bolt has fallen for certain time. So with respect to ground, we need to analyze the thing of volt. And so suppose the volt has fallen and this lift is also moving. It has acceleration 1.2 meters per second. So suppose the bolt is fallen and this lift has come to this. So if we need to measure the displacement, so displacement is only this much, not 2.7. So this displacement, suppose I have found H. So this displacement we need to find with respect to ground. So I will write as volt with respect to ground. That is given as up to H height 2.4 meter. It has gained some velocity, and the velocity we have already known as 2.4 meter per second. It will be 2.4 meter per second. Now, so this height H, so I will write as formula H that will we are depicting from here. It will be minus H equal to UT. UT will be 2.4 into T and minus of half GT square. And this T time we have found earlier, that will be 0.7. So H will be 2.4 into 0.7 and this will be 9.8. So 4.9 into 0.7 into 0.7. So it is coming exactly about minus of H. It will be 0.7, 2.4. It will be 7 4 28, 28, 28, 14, 16, 1.68, 7 4 28, and this will be 4.9 into 14, 49 again. 49 into 49 will be, so it will be coming 94 means 4.9 into 4.9 into 8, that means it will be minus of 2.401. It will be 2 and this will be 7 means 0.7 minus 0.72 meter. So H equal to 0.7 meter, which is the correct answer there. Also we have got. So our displacement will be minus 0.7 meter only. And if we consider about the distance what the bolt have traveled, so we can have another diagram for that. Coming back to this diagram. So about distance, I can say that about if I need to find the distance, so I can draw here. So this is the situation basically. Bolt is released So as per the ground from here, I can see that it will look like it because the elevator is also moving upward. So it will go like, so it has started from here. So it will go like this, and then after come to this point. So this is my total distance, and in that we have found this h. H we have already found 0.7. So we need to find this distance. Now, at this point, elevator have a speed of 2.4 meter per second. 2.4 meter per second. So I can write as final speed when it goes to the top will be 0. So v square equal to u square minus of 2g. So I will write as x, y1, 2g y1 minus. So y1 we have got, y1 will be 2.4 into 2.4 upon 2 into 9.8. I hope you understand this thing. So it will be 1.2, and this gets cancelled. 49, it will be 6, and it is also coming about 6 into 2.4. So it is coming about 6 into 2.4 divided by 49. So it is coming at 0.29, 0.2938, 0.2938 into twice, because we need to measure both distance, this distance also and this distance also. So it will be about 2 times, if I will do, so it will be 0.58 meter, or I can say it will be 0.6 meter. So the required distance we got as 0.7 earlier displacement, this displacement h plus 0.6. So I have got about 1.3 meter, and this is the answer to this final question. I hope you understand the concept, although my writing is not so good, but you understand the concept, how to do these kind of problems. So thank you so much for joining.